Soccer, also known as football, is a popular sport enjoyed and played by people from all over the world. It is a sport played by 275 million people all around the world. The game requires players to kick the soccer ball with their legs and score it to the opponent's goal post. But, have you ever wondered about the physics behind this sport? Let's take a shot and dive into some physics concepts revolving around soccer. In this video, we will be discussing about rotational kinetic energy, Newton's law, projectile motion and Magnus' law in soccer. We will be starting with rotationary kinetic energy. Have you ever wondered how and why a soccer ball keeps spinning during a game of soccer? Rotational kinetic energy possessed by the soccer ball keeps it rotating, and it is directly proportional to the rotational inertia and angular velocity. Assuming the ball has a rotational inertia of 3.63 kg per meter square and a boy spins it with an angular velocity of 150 radians per second, the ball will possess a rotational kinetic energy of 40.8 joules. Now, let's take a look at how Newton's law of motion is applied when the dog is kicking a stationary ball. Newton's first law of motion states that an object will continue to stay at rest or move with constant velocity unless a resultant force acts on it. Newton's second law of motion states that force is the rate of change in momentum, and for a constant mass, force equals to mass times acceleration. Assuming 10 newtons is exerted on the ball, and the ball weighs 450 grams, we can find the acceleration of the ball to be 25 meters per second square. What if the ball is kicked diagonally upwards at an angle? The ball moves in a projectile motion through the air. Its motion can be divided into vertical and horizontal components using the following equations. The magnitude of each component is independent of each other. The vertical velocity is affected by the gravitational force, while the horizontal velocity is affected by air resistance, which often is negligible. At the highest point, the vertical velocity is zero while the horizontal velocity remains constant. Now we will be discussing on the physics behind curved ball. Ever wonder how soccer players can shoot a curved ball around a 5-people wall during free kick? The ball can be explained by the Magnus effect. When a soccer ball is kicked and curved through the air, the ball has to be spinning. As the ball spins, the air splits around the ball. One side of the air travels in the direction opposite the spin, and the other side of the air travels in the same direction as the spin. This creates a thin layer of air dragged around. As oncoming streams of air pass the ball, the side that is moving in the same direction as the spin follows the curve of the ball and is deflected off. The side that is moving against the spinning ball meets opposing air and cannot continue around the ball. Newton's third law of action-reaction produces a force opposite the direction of the curved stream, which pushes the ball horizontally. Therefore, this can result in a ball deviating as much as several feet from the original trajectory by the time it reaches the net. While soccer may seem like an easy and effortless sport, the game relies heavily on physics. Soccer would not be played unless physics had played its role in the sport. Through this video, we hope that various physics concepts can be better understood by relating it to the familiar game of soccer. Now that you have understood the physics behind soccer, go and try it out to see if you got any better. We hope that you have enjoyed our video. Thank you for watching.